Good evening, everyone, and welcome to our roundtable about mitigating the risks from catastrophic pandemics. We are thrilled to have you all here today, despite what's happening on campus. My name is Alex. I'm co-director of Effective Altruism Switzerland, where I am providing support, resources, training, and connections for people to figure out how they can most effectively contribute to making the world a better place. And in that context, I have organized this discussion panel. As you might have heard, we are recording this iteration of the roundtable. So if you don't want to end up on our YouTube channel, well, you can ask questions at the Slido, but maybe don't speak out. Otherwise, over the next hour and a half, we'll be diving deep into biosecurity with insights from our distinguished panelists. This event seems rather timely, as we will celebrate on Wednesday 44 years of a smallpox-free world, since WHO officially declared the eradication of the disease on May 8, 1980. Each of our panelists is bringing their unique perspective and insights. We'll start with Gregory Lewis, who works as a biosecurity consultant for a mix of grant makers, think tanks, and NGOs. Before that, he worked at the Future of Humanity Institute at Oxford University, and before that, he was a public health doctor. He holds a PhD in mathematical biology from Oxford and a medical degree and Master of Public Health from Cambridge. Greg will kickstart the conversation with an insightful overview of scope-sensitive biosecurity, shedding light on the nuanced approach needed to tackle modern-day challenges. Sorry, I forgot to add throughout the presentation, you can submit questions using Slido. So you can go to slido.com and enter the event code, or just simply scan the QR code. Feel free to address a specific speaker in your questions. In Slido, you can also vote for the questions you like most and help me select those who are most relevant for the audience. We'll address as many as possible during the Q&A. And yeah, if you want to ask questions as they arise during the presentation, I suggest you scan the QR code right now. And after the Q&A, you will be able to grab some snacks and interact with our panelists. And I'll encourage you to take this opportunity as they are coming from abroad for this event. Without further ado, I'll give the floor to Greg.
Perfect. Thank you so much, Alex, and thank you all for coming along. So I'm going to talk a little bit about, I guess, why you should care about this and what in particular amongst the field of catastrophic pandemics one should care the most about, because both come in a variety of forms. There we go. One obvious reason, most salient in terms of catastrophic pandemics, is of course COVID-19, which people may be sick of, but has not yet gone away. The death toll, as officially accounted across the globe, is about 7 million people. That number is almost certainly too low, because many deaths which were due to COVID were not recorded by health authorities as COVID. Estimates of that are very hard, but you get figures of the order of like 20 to 30 million people. That's a bit less, well, between 0.1 and 0.3% of the world population died from this disease. If we were, however, doing a league table of the worst events humanity ever suffered, it would nonetheless find itself quite a long way down the list. Here is a selection by Luke Mulhauser, which may not project so well, I realize. But you see on this list are things like the First World War, the Second World War, events of Stalin and Mao Zedong, and so on and so forth. These figures often give proportions of the world dying between 1 and 10%. What's interesting from a public health perspective, or from a doctor like me, is pandemics are often present amongst these worst things to ever happen to the human species. The things I've highlighted are the 1918 influenza pandemic people may have heard of, a more rarer plague pandemic in the 500 or so year Common Era, so-called the Plague of Justinian, and topping the chart, if you excuse the term, is the Black Death, which, although figures are very hard to estimate, killed some between 1 and 10% of the world's population, a lot of people. What's notable, at least for me, is that the pandemics or outbreaks have like a very wide span of severity. So people may recall after COVID-19, there was a scare about something called Mpox or monkeypox, as called at the time. There was worries they'll be very avidly transmitting and be quite similar to smallpox, which was eradicated as I said, 44 years ago, almost to the day. Mercifully, it turns out it didn't transmit quite so avidly as we had feared, and so it, if you excuse the term, only killed so far 200 people, which is by no means trivial, but is much better than feared. If we track our minds further back, we might recall other outbreaks which were somewhat more severe. So before COVID or SARS-CoV-2, there was indeed SARS-CoV-1 in the early 2000s. And there was also a variety of outbreaks of Ebola virus across Africa. These events killed between 1 and 10,000 people. If we now extend even further, we might talk about events like COVID-19, as already mentioned, or the 19 influenza, which killed yet more people again. But there might be like another order of magnitude, literally in this case, in terms of severity, which we might begin to talk about what I would consider a more global catastrophe, something even worse than COVID, even more devastating, which caused even more damage. Of which perhaps the only thing which is beginning to approach that was indeed the Black Death, which was 500 years ago. I think we should still be worried about such events in the current day. So I've talked a lot about sort of big outbreaks of infectious diseases. And in terms of why should we particularly care about this, that could be argued because endemic infectious diseases and diseases which don't have outbreaks happen all the time obviously kill many, many people every single year. HIV was once a pandemic, but is now probably an endemic disease and kills people even now. Smallpox was endemic before it was eradicated. So why should we put a particular priority on focusing on these outbreaks? And as I will argue, on the very severest ones. There are many, many more frequent, less severe outbreaks. They seem important too. Why am I so monomaniacally focused on the very worst events? Well, one reason is that the numbers do matter and they do add together and multiply up. And it seems that for certain events, pandemics not least amongst them, they have this very skewed distribution where the vast majority of the damage is caused by very small numbers of singular events. So mentioning those pandemics I mentioned just before, like monkeypox or SARS-CoV-1, COVID-19 was like hundreds to thousands of times more severe in terms of total death toll and didn't happen much more commonly. So if you're trying to track the number of people who died in an infectious disease outbreak in, let's say, the last 50 years, almost all of these deaths were due to COVID-19. And so there's a story for focusing on the largest events, particularly because although they are unfortunately the opposite of a Goldilocks zone, whereby they are rare enough that they can be over time forgotten, but not so rare they are trivial. One thing in my field, which we're commonly aware of, is this thing called the panic and neglect cycle. So you have like a really big event or a disaster, such as COVID-19. And if people maybe recall how they were like 2 years ago, possibly under lockdown, there was a lot of urge like, oh, we need to like really, really fix this problem. Nothing like this can ever happen again. We need to build back better, as it was termed in my country. And so there's like a pile of activity and effort to try and do that. However, as time goes by, we're only like, to be fair, 2 or 3 years after the height of the pandemic, but you start getting complacent and maybe you get false alarms. So this fear about mpox being the next big thing didn't have to be mercifully so severe. People might recall from 2009, there was a major scare of a flu outbreak of bird flu, which again turned out not to be as bad as feared. Whereas obviously ongoing a concern about new flu variants arising as we speak. Maybe that will be, as it were, a big one, but maybe it won't be. And so time goes on. And so as these things happen reasonably rarely, although not rarely enough, there's enough time for this to be considered not a big problem anymore. People get complacent and you're roughly back to where you started until the next disaster occurs, on which I'm sure much more from Jasmin later in the show. So one reason why I care about these events is, in a sense, there's like a cognitive blind spot amongst humankind to not pay them appropriate attention, because although they happen rarely, they are so dangerous, there's worth insuring yourself against them, which generally we've failed to do. However, another reason why I care about these events so much is because I worry that about events which are so severe, they do not only serve as scars on humanity's history, but credibly threaten its future. So one account, which is my own preferred account of global catastrophic risks, are those which are so bad they permanently worsen humanity's future, or indeed just kill everyone, and so end it. And the reason I care about this so much is it seems, amongst other things, there's a lot of future people out there all going well. To put this in perspective, the tiny triangle in the center of that diagram represents all 8 or so billion people alive at the moment in the present day. Many more people have lived and died in humanity's past over the last 200 or so thousand years, although most of those have been living close to the present because human population has grown dramatically since the Industrial Revolution. So maybe I could invite you to imagine this. So let's suppose humanity as a whole gets its act together and all goes reasonably well. So the population on current trends and current demography will stabilize at roughly 11 billion people around the globe rather than the 8 or so at present. Although life expectancy remains low in many parts of the world, let's say that is collectively fixed. So everyone in the world can expect a quality of life and lifespan similar to rich countries, such as Switzerland. So roughly 80 to 90 years. And then we assume the show goes on for our species about as long as any other mammalian species we know of, which have an average lifetime, if you will, of 1 million years. So we've had 200,000 of these so far. There's another 800,000 to go. So given all these things, how many people could there be all going well, or all going reasonably well? And you get a figure like this. So there's a lot of triangles in that figure. Happily, someone counted them for me, and there's about 12,500 of these triangles, corresponding to a future population of 100 trillion people, all going well. And one may hope things would go better. For example, one may hope that as we are somewhat smarter than the average bear or average mammalian species, we could live a lot longer collectively. If we do well, we might think we could get a lot richer. We could do all sorts of things with a lot of time available. I used to work at a place called Future Humanity Institute, and so if you want to start engaging in imagining sci-fi, you can imagine going to other bits of the galaxy, spreading out more widely, all of this jazz. But all of that relies on all going well. So this is why I focus particularly on threats I'm concerned about which could put this future in jeopardy or in doubt. Yet, what I haven't really said is why does this apply to pandemics? Why does this not apply to nuclear warfare or climate change or asteroids or alien invasions? And one can obviously stipulate all manner of things which could be an existential threat, but why think pandemics should be on the list? I think the answer varies, and I think the answer is they do, but maybe not the ones by and large we've typically seen so far, by which I'll explain. Because my view is that in terms of, we've never yet seen, and hopefully never will see, a pandemic which incredibly threatens humans' future. Even things as awful as the Black Death never credibly posed a threat to the species as a whole. And I think the reason for being, relatively speaking, reassured is simply that because it hasn't happened yet, it is unlikely to happen in the future, which is an argument one should use cautiously, but I think it does check out here. Humans survive hundreds of thousands of years without being wiped out by an outbreak, and furthermore, that other species very rarely go extinct thanks to infectious disease gives some reassurance that reasonably likely to happen in the future, although it's not guaranteed. One might well say, and one should say, that the recent past has been very different from our evolutionary history in a number of ways, many of which could increase the danger, and many of which are talked about extensively in public health, because we now travel much more widely. We have things like cities with much denser populations who communicate more. There's obviously ongoing climate change, which could disrupt the environments around us and so cause bugs to spread from other species to our own. Or indeed the fact we rear and, you might say, manufacture vast quantities of animals for food means that we are in much closer contact to all these diseases. And that's the common pathway through which many of these big outbreaks of the past, we think, first made its way to infect humans. However, there are some upsides as well, thanks to modernity. we do have modern medicine. The COVID-19 pandemic, for all its costs, did have the triumph for the first time a vaccine was developed from a bug being discovered to vaccine being delivered to people. Took under a year, which is never before seen. One may hope this delay gets a lot shorter in future. We have things like hygiene, sanitation, understanding of how diseases spread, all of which can help. So my quasi-expert opinion would be, if you add these two things up, or these pros and cons up, you get roughly a wash. So if you think, as I do, that naturally arising pandemics can be very bad, but not an existential threat, if you will, I don't think that's changed a lot in the last 50 years, although it's been modulated up or down by how humans have changed. What I think has changed a lot and in the bad direction is capabilities of people either doing something very stupid or doing something very nasty with biology, in which would cause a lot of harm and maybe develop pathogens which are more dangerous than seen by Mother Nature. In a soundbite, nature may not indeed be an insurpassable bioterrorist. And things which occurred previously, thanks to, as it were, evolutionary accident, could be surpassed by deliberate design. So one example of people doing maybe foolish things, going back to COVID-19, is a paper, this is an example of, there'll be many papers like this. This is the most recent example, published in 2021, during the height of the pandemic. And in essence, this paper is a how-to guide for if you have a lab, how to genetically engineer your own variant of SARS-CoV-2. You might think that may be somewhat unwise. I agree. What's the dark irony of this paper is when you write what's called a protocol paper like this, you do actually include warning signs of to warn people of what they're doing. And the warnings included in this paper were things like, to do this experiment, you need to use a water bath of a certain temperature, so be careful not to scald your hand. Or this chemical you're using can cause cancer if you dip your hand into it, so please wear gloves. Nowhere mentioned do not deliberately engineer a virus currently responsible for the largest public health disaster since HIV and see what happens. Alas. Now, obviously the people doing these things are not just malicious, or they might be foolish. And it might be okay, you might think, if they play this stuff in the lab and it just stays in the lab, it will never be a problem. Unfortunately, of course, labs are not perfectly safe. And we're not entirely sure how unsafe any of them are, unfortunately, but it's probably not great. People may well be aware, obviously, there's ongoing controversy about the exact origins of the COVID-19 pandemic in the past. Maybe it was a lab outbreak as well. And even if it wasn't, there's wrong word. There's an interesting data point whereby one of the earlier and milder flu outbreaks in 1977, we think was probably some sort of scientific accident because it's genetically basically identical to a virus isolated in the 1950s. It's not probably like a lab accident or a vaccine trial gone wrong, but humanity has formed for maybe doing quite foolish things. And now you can play with engineering and much better biological design, maybe that could go wrong. Besides people being stupid, they can just be extremely nasty. Fortunately, this is ruined, but at its height, this was one of 13 massive facilities by the Soviet biological weapon program to do stuff like produce industrial quantities of smallpox, trying to modify Ebola, trying to evade vaccines and therapeutics, making the bugs they are making difficult to detect, and so on and so on. If you imagine an archetypal supervillain list of things that might to do with biology, most of them you could probably find somewhere in the bowels of this program. We hope, for example, that Russia, after Soviet Union, is no longer doing this anymore. They say they aren't. But these programs have occurred in the past and probably will continue to occur in the future. And even if all of the states do both sign up to the Biological Weapons Convention and keep their word, there may be other groups, non-state actors or terrorists, who might use these as a weapon. The ruins there were using biotechnology now 40 to 50 years out of date. It's probably much easier now, and they could probably do much worse if similar things existed today. Hopefully they won't. So that's the précis of why I think this area is really important, that Obviously, pandemics are bad. I think the worst pandemics are really, really bad, especially those which threaten humanity's future. And I think that danger disproportionately arises from, rather than Mother Nature, from human activity which is either unwise or malicious. It would be good if this problem gets fixed. In terms of how to do that, that is, of course, much easier said than done. One nice thing is, of course, people like me are not working alone, and there's entire communities working on non-pandemic stuff, which is still relevant. Things which help for small outbreaks often help for larger ones. So the hope might be not only to generally increase this effort across the board, but maybe also trying to find ways or find measures which are particularly valuable in terms of reducing these very worst case scenarios, reducing both their likelihood and trying to mitigate their severity. Obviously the how to do that is very unclear, but happily, I have others who can cover me from that. Thanks very much.
Thank you, Greg. Thank you so much. We'll continue with Jasper, sorry. with Jasper. Jasper Götting is a research fellow in the, Jasper is a research fellow in the biosecurity team of Convergent Research, where his work focuses, among other things, on road mapping for UVC air disinfection technologies and clinical metagenomic sequencing. He previously completed his PhD in biology at the Hanover Medical School, where he worked on sequencing, evolution, and transmission of viral infections in the transplant setting. Jasper will present the technical perspective, giving an overview of the latest advancements shaping the field of biosecurity.
Yes, thank you, Alex. Thank you, Greg. I hope you're all now motivated that pandemics are bad. I hope you were already motivated before the talk. I kind of want to start that, of course, you know that we are not defenseless against pathogens. Greg already laid this out a little bit about the dividends of modernity. We are not as defenseless as the plague-stricken Europeans in the 14th century. You've been through the pandemic, you know of all the nice benefits we had to protect you from infection. We had very good PPE, we had masks you could wear and still meet people. We had rapid antigen tests, which you could use to test yourself, to trace infection chains, prevent infections. And of course, the mRNA vaccines, biotech's darling right now, which were ready just at the right time to very briefly, just in a couple of months, roll out from initial design to actual vaccine that prevented worse diseases. But given that Greg outlined, we are also a lot worried about the engineered stuff, which might be able to circumvent some of the evolutionary constraints around virulence and transmissibility. Some of the technologies and approaches we currently have might just not suffice in that defense. And going back to Greg's slide, I want to briefly lay out what on the kind of x-axis portfolio is, what are the kinds of technical interventions we would like to see which protect against the worst case engineered pandemics. And kind of bottom line, what we want are interventions that are effective across, pathogen agnostic, because we don't really know what will come in the future, and ideally multi-layered, we have a very broad defense against very different pathogens and against various kinds of stages of a pandemic. And one useful model I want to introduce for structuring these tools concerns the when, meaning at which point of the pandemic we can intervene most effectively. And if you imagine a pandemic, at some point, time point 0, you have the very first infection, then the whole shebang exponentially spreads, and at some point you might have this global catastrophic biological risk or even extinction. And we can split a response against this idealized pandemic into basically 3 intervention buckets. You can call them prevent, detect, respond, or delay, detect, defend, doesn't really matter. It's pretty straightforward. Either you prevent the very first infection, so you never have a pandemic to worry about in the first place, or you detect the pandemic as early as possible, and you want to detect it as early as possible because then you can respond as early as possible and defend and mitigate all the negative consequences. And I'm going through these three buckets and highlight like one especially interesting intervention and one interesting approach in each of these buckets. Starting with the prevention side, here it's mostly about either constraining the capabilities of actors who want to do bad things with biology. And if that's not possible because the actor might be a state, which can basically do anything, then we want to shape the motivation so that biology basically becomes unattractive as a means to achieving some goal. And on this constraining part, one very topical and interesting topic concerns the AI bioconvergence, the era of AI-enabled biology that we're currently entering. So you all used LLMs like ChatGPT or Claude. They are trained to help you with stuff. So it didn't really take long for people to ask questions like, can these large language models democratize access to dual-use biotechnology? Or also nicely phrased title, will releasing the weights of future large language models grant widespread access to pandemic agents? Pretty good questions, if you ask me. There were some follow-up studies by RAND and OpenAI, and the consensus is like, current LLMs, not so much. They barely uplift people, but future large language models, sure, they're pretty well knowledged. They're extremely helpful. You can circumvent some of the defenses. Jailbreaking is a huge thing. So you might imagine this toy model where most people in the population, can you see my mouse? No, you can't. Most people in the population have absolutely no capability for misuse, and basically the people who can misuse biology are a couple of like virology PhDs, professors, so on and so forth. And LLMs might just raise the general capability waterline. They don't really push the frontier. They might make experts a little bit more productive, but that's not really the worry. But there's this other kind of AI model, or BDTs, or biological design tools, models trained on huge swaths of biological data like AlphaFold, which recently solved protein folding. And they are hard to use, but really push the frontier of what we can do with synthetic biology. And the worry, of course, is LLMs, LLM agents, which will soon be there, can use tools, can use APIs. So we might have at some point the stage where you just ask an LLM, it plugs into some BDT, it designs you whatever you want. And one very nice thing you want to do to prevent this, of course, is safeguarding this digital to physical frontier, we call it, which means preventing people from taking whatever data they have, whatever pathogen genome, and turning that into an actual live, viable virus that can infect people. There are very nice, interesting cybersecurity questions around that. For example, how do you manage access to sensitive biological data? How do you set up databases which contain pathogen genomes? Of course, you want to evaluate the models themselves. Do they contain dangerous information? Can you somehow exclude that from training runs? But also a very nice approach is DNA synthesis order screening, where essentially you screen every order for synthetic DNA and RNA that is out there in the world and determine, is that fine? Can you produce that? Can you turn that from digital to a physical sequence? Or if not, prevent that order from going through. And a couple of organizations working on that, SecureDNA and IBIS with the common mechanism, they're basically trying to get all the DNA synthesis companies and benchtop synthesizer manufacturers to adopt DNA synthesis screening. So eventually it basically becomes impossible for somebody with access to DNA synthesis to manufacture something that is potentially dangerous, like part of a virus genome. The detection bucket is a bit simpler. It basically includes every technology that enables us to detect emerging pandemics quickly and robustly. That includes, on the one hand, clinical and environmental metagenomic sequencing, where you just sequence all the DNA and RNA in a sample, either clinical sample, like blood sample, people that randomly go into the ER or to the GP, but also environmental sequencing, where you sample wastewater that was done during COVID already, but rarely with a deep sequencing approach, which was pathogen agnostic. We also ideally want pathogen agnostic diagnostic platforms, which you can quickly adapt to pathogens. Imagine you take a lateral flow test to see whether you got flu, but at the same time, the test also checks for, say, all coronaviruses to see whether there's something new circulating. And of course, digital pathogen surveillance, which integrates genomic, public health, travel data, digital data, tweets, Google searches, whatever, to understand whether something is spreading right now. And to briefly zoom in on the environmental metagenomic sequencing, kind of the idealized world we would like to see includes something like the Nucleic Acid Observatory, or NAO, a project that is currently underway, which aims to basically once a week or so sequence water samples from waterways, wastewater, airports, and do very deep metagenomic sequencing to see whether anything is in those samples that we haven't seen before and whether that's exponentially spreading. The brief workflow: you take a sample. You can do this with water samples, wastewater, like I said, also clinical samples. You remove you extract the nucleic acids, you amplify them or don't, multiple approaches. You sequence them really, really deep. So basically get the sequence of every piece of nucleic acid, DNA and RNA in that sample. And then you can either detect known hazards, say coronavirus genomes, or you just detect something that you haven't seen before, but it's spreading exponentially. Like it wasn't there before, like it wasn't there last month. It was there at a very low level last week, and now it's much higher. And that gives you the indication, okay, something is multiplying somewhere out there, and you can figure out what it is and potentially respond early, which is, of course, the last bucket. Every technology that helps us contain, mitigate, or survive pandemic. You are also probably familiar with those things. That includes, of course, PPE, like masks. But the thing is, the masks and the PPE that we currently have probably won't cut it in a worst case scenario. If you imagine a scenario where, I don't know, a pandemic is like 50% lethal, and it's basically a coin flip whether you die if you get infected, and then you still need to maintain the food supply and the power grid, and you give those essential workers an N95 mask and say, now go out and do your job. They probably won't do it. They'll probably be very reluctant. So what we ideally have is a large, well-maintained stockpile of pandemic-proof personal protective equipment, or PFOE, which includes like suits, peppers, which are powered respirators, like a whole bubble around your head with a large filter and air supply. Anything that really makes sure there is zero chance of you getting infected if you go out, do your job, and interact with other people. We, of course, also have medical countermeasures, or MCM, and ideally platform technologies like mRNA vaccines, which can be rapidly adopted to novel pathogens. CEPI, one of the larger vaccine alliances, is currently working on a 100-day vaccine model where within 100 days, you want to have a vaccine ready to any new threat out there. But also like universal antivirals like Vertex, which is a new form of antiviral that potentially works against any form of virus in any viral family. And lastly, one thing I briefly want to zoom into are infection-resilient environments. We currently have absolutely no issue with our water. You don't get sick 3 times a year from drinking contaminated water, but it is still the case with our air. We do have respiratory diseases and the flu season, and we kind of accept that, but that's absolutely not necessary. Like, we have the technology to make our air potentially as safe as our water, and we should actually do it. And the magical word here is germicidal UV radiation, or germicidal UV light. Very briefly, just a brief download. We have the UVA and UVB in sunlight, which gives you cancer. You should avoid that. Always wear sunscreen. And we have the UVC range, which is germicidal. It kills bugs because it destroys their DNA. The conventional GUV has been used in water disinfection for over a century, very tried and true, but also hurts the eyes and skin. But in the last decade, people found out that if you go even further down in the wavelength range, you hit far UVC, which is between 200 and 235 nanometer. And that is absorbed by proteins. It can't penetrate your skin, it can't penetrate your eyes. But microbes are just so tiny that it still disrupts them. And now, evidence is mounting up that this works extraordinarily well at disinfecting air. And we should, in fact, be working on that technology and implementing it more widely, especially in like public places where a lot of people interact and talk. and get to that ideal future where our air is just as safe as our water. So summing up, we've seen some highlights in those buckets from prevention, detection, and response, mostly on the technical side, of course. But going back to prevention, ideally, we want to be in a state where that isn't an issue at all, where people aren't able to take a pathogen, engineer it, and cause a pandemic, because we have the right incentives, we have the right structures, we have the right governance, and the right culture around that, so that all this isn't really an issue. And on that, Jasmin will now speak. Thank you.
Thank you, Jasper. Now I would like to welcome Jasmin to the stage. So Jasmin Kaur is a biochemist with training in genetics and developmental biology. She also worked in biopharmaceutical science to evaluate disruptive technologies, such as machine learning trained imaging pipelines for cell detection. During the COVID-19 pandemic, she became passionate about large-scale policy interventions that address biological risks, such as pandemics and respiratory pathogens. After co-founding a grassroots advocacy organization for biosecurity, she now leads the UK strategy for One Day Sooner as director of UK advocacy on the use of human challenge trials and building medical countermeasures against biological threats. So Jasmin will conclude this presentation by exploring the policy landscape, providing valuable insights into the implications and consideration that guide effective biosecurity and pandemic preparedness policies.
Thank you, Alex. Hi, everyone. It's really good to see you all. The way I'm going to walk through sort of the policy section of this talk, I think you've heard some great ideas about, firstly, why biosecurity risks are really important and we should be paying greater attention. And second, what are some of the technologies or interventions available to us that could help tackle these problems to some extent? The way I really see the policy angle here is then how do you take all this information, interventions, and technologies and put in the hands of people who actually have the power and the purse strings to implement these solutions on large scale and make sure they're sustainable and well integrated in how everyday people live their lives. And pandemic preparedness, I think, is something that a lot of smart people had been thinking about for a while before even COVID-19. But of course, after the pandemic, it has received much greater attention as needed, really. And the phase we're working in right now, or a lot of the actors who are in the pandemic preparedness space, is how do we take a lot of the important lessons we learned from COVID-19? How do we forecast into what future risks we expect, what kind of pathogens these could look like? And then how do we measure them against our current interventions, whether these are infrastructure, supply chains, or technologies, and how well they really stack up against these risks. Just to give you a sense of some of the various bills and policies floating around the world, so to speak, and just like a very small taste of that. So right now, in terms of think tanks, in terms of like policy and advocacy organizations working on this issue around the clock, there's a lot of exciting proposals going around. I think some are a little bit more ambitious and closer to the finishing line than the others are. Some are sort of very nationalistic. We're still struggling to get people to work together, which should be obvious given it's a bio threat, but sometimes it's really hard to get going. So some sort of like key ones that I'll point out, especially if you want to like go and read a bit more on what these bills might contain. So a piece which is like very biased, closer to the heart, is the UK Biosecurity Strategy from 2023, which I think contains some really good pieces, not just on naturally occurring zoonotic transmissions, but also engineered threats. The other, I think, the HERA work plan by European Union, which has like billions of dedicated budget to actually get some really ambitious things done, including a lot of interesting funding calls for far UVC. China is currently in plans or amending its biosafety law from, I think this bill was from like 2019 was the original one, which actually is also looking at how to protect China and its interests against engineered risks from its neighbors or other entities. There's the famous PAPA, which I think stands for Preparedness, All Preparedness Agreement or something. I never know how to say it. The PAPA bill in the US, which is again going through a lot of amendments, but I think has some like ambitious things in the pipeline. And probably sort of like central to all of this is the WHO Pandemic Preparedness Treaty, which after sort of like 3 to 4 years being in negotiations and constant talks at World Health Summits, is coming to a little bit of an end this year. I think we'll probably end up a world where we have a WHO implemented pandemic preparedness treaty, but how well is it resourced, and then what good a job it actually does at protecting us, I think is like a whole different segment and a whole different thing that we should discuss like in another time. Something exciting, which was like kind of my bedtime reading last night, which made me really happy, was the dual use research concern bill that just came out in United States, which I think is like really exciting. And actually, as Jasper was indicating, contains mentions for oversight on biological design tools, which is probably the first time I've seen this come out in a US act, which I think is like really exciting. So I definitely recommend checking this out if you're interested. I'm going to go back to what Greg already introduced to you, which was the pandemic to neglect cycle. Across this landscape of pandemic preparedness and different countries and actors working, I think a common pain point that a lot of actors or a lot of people in this space share is definitely making sure that the right people have the attention at the right time. So something that I'll just put a QR code in case you're interested. So the World Bank did a really interesting paper just before the COVID-19 outbreak, which looked in much greater detail in all of these different phases of policymaker attention on a given pandemic preparedness cycle, which starts out with a lot of negligence. There's a lot of denial. There's a couple of strains in transmission, but often gets lost in what we call the daily politics. Usually then some experts start arriving on the scene. You have like what looks like early stage meetings, for example, in a country like UK, but which Prime Minister decided not to attend at the time, and that's a different issue. And of course, like the time that we start pouring in resources a little bit too little too late, you have overwhelmed health systems. We then sort of like start to transition into this state of reflecting on what went wrong, what we should have done better. There's a lot of sort of ongoing work streams in this, like UK is running its COVID-19 inquiry, which will finish in a couple of years. I know it's like still taking a very long time, but it's meant to be this very extensive document, public-facing document, and everything a country like UK did wrong or should have done better. And I'd say we're sort of in the inter-pandemic negligence stage right now, where you see a lot of the resources starting to dry up. And when I say resources, this could mean funding. There's not a lot of new money around. I think during the pandemic, a lot of philanthropic funding was pouring into, federal research agencies was pouring a lot of money into, but that's sort of like starting to dry away. Again, I think it's like really hard to get attention in health departments or in everyday politics from people and get MPs and ministers concerned about why we should still pour more into pandemic preparedness. I'm going to stick to the framework that Jasper was already introduced you to, which is just to give you a snapshot that if you're someone who's thinking about bio and policy in sort of the same domain, as interested in this, what are some of these interventions or what policy at these different pain points and intervention points could look like. So just to give you a snapshot, starting from probably arguably the most effective of these all, which is policies that help prevent a pandemic in the first place. So an example here, which I think is still very much, I think a lot of people are excited about this, but it requires a lot more thinking through, requires a lot of negotiation. And I think something that's still missing is probably a lot of the representatives from middle and low income countries and what their vested interest in a policy like this might look like. So one example here, the first one is a pandemic test ban treaty, which kind of takes birth from or being inspired from the nuclear ban treaty, which the idea is to try minimize the damage of research that might trigger outbreaks or pandemics and try maximize our benefits with ongoing research interventions in this space. The second one, which is kind of inspired by, interestingly, like the housing and insurance market, which I thought was like really interesting, is a liability insurance for catastrophic outcomes. And essentially the underlying idea is if there are entities, this could be pharmaceutical companies, this could be a research lab, biosafety level 3 or 4, who are performing dangerous research that ends up affecting negative outcomes in the world. If, for example, this could be a lab leak, they are held responsible for their actions, financially and otherwise. And populations who might be affected by this. So this could be people who live in like a neighboring state where a lab leak has occurred, are compensated for any losses that they've incurred in this process. Third, I won't go into too much detail because I think Jasper's done a great job already touching on this, is more from some of the governance framework for policies that help manufacturers or industry players or states to agree into sort of commonly by DNA synthesis mechanisms. The second category here, and again, I've thrown sort of like quick fire examples here, is detection. This could look like wastewater surveillance or maybe sort of like more sensitive measures. This could be like CRISPR-based detection technologies. And then second here, which I will go into a little bit more sort of example walkthrough, is your preparedness measures. So this is your global library countermeasures that help you protect against these pathogens. Third and final category here is how do you respond to a pandemic that's already ongoing or happened? And this can range from sort of behavioral outbreaks. So this tends to be your quarantine measures that local governments might put in place to sort of PPE. And of course, we have sort of far UVC, which arguably I think could also be under the prevent umbrella, like how you want to look at it. We're gonna take, this feels a little bit sort of like abstract right now, is like you have an idea, you try to bring into like reality using some policy tool. So let's like pick one of these things and try to do a little bit more sort of like a practical walkthrough of like, what are the pain points where you take an idea and actually try to turn it into policy. And I think the one that probably makes the most sense is stuff I've been sort of like thinking and working on for the past like couple of years. So let's pick one branch from that and try to think about what does it actually mean to turn it into a physical implementable policy. So this idea in the world that I think a lot of actors are excited about, which was introduced by CEPI, which interestingly was a sort of like co-parented by UK when it chaired the G7 summit in 2021. So UK is supposedly like an actor trying to help the 100 Days mission get implemented. But I have my own personal takes on how well UK is doing that right now, which I won't get into too much. So you have the 100 Days mission where the idea is we are able to respond into any future outbreak in 100 days or even better, less. And what's really like a pain point that we see with some of this is that, I think the text is a little bit moved, never mind. Something that we see a little bit of a pain point with the 100 Days mission is that currently the plans are that for any countermeasures that we might develop as part of this like global encompassing library against pathogen are only done up to phase 2 of clinical research, which means effectively in your sort of like life cycle of producing any type of countermeasure, all you've done is prove it's safe in humans via your phase 1. And you have some measures of the required vaccine dosing that you might need during an outbreak via a phase 2. But you're missing some really important correlates for how effective this vaccine or antiviral is likely to be. How do you actually understand sort of like mucosal endpoints for vaccines that not only help reduce symptoms, but actually block transmission, which I think is the next phase of vaccines we need to be hitting into. And also some immune markers that help distinguish what you might declare a vaccine as doing its job well, and put in simpler terms. And this life cycle of producing research is just like super expensive. So as you go sort of like from phase 1 to sort of like phase 3, the amount of money that you spent in this research like scales at a crazy rapid speed. And this is where sort of a policy idea that we've been playing with, that we're working on sort of like right now, was the idea of human challenge trials, which is trials that sort of sit between, I'd say like your phase 2 or phase 3, effectively replacing phase 3 studies altogether if needed. Like we produce cholera vaccines in the world using just a phase 2 and a challenge model. We did not need to do a phase 3 to get approval. which could actually help accelerate a lot of these countermeasures and make sure that much further along the pathway. So if you look at in practice, what does this actually mean for our 100 days mission and our library of global countermeasures, again, pandemic pathogens? So if you're conducting these studies in an interpandemic state, which arguably is the state we're in right now, you take your countermeasures library and then you run them through a human challenge model. So when the next outbreak does happen, you effectively have measures for mucosal immunity, you understand transmission way better for any pathogen, and you actually have a choice between being able to approve a countermeasure using a little bit scaled phase 2 model instead of having to do a phase 3 in every case, which cuts significantly on the amount of time and money you're spending making any vaccines, antivirals, or diagnostics for any pandemic pathogen, especially a respiratory one. That's the idea in a nutshell. And then comes the question of like, who are the people responsible for turning this into an actual policy, and how do you get their attention? This is like still meant to be like more simplified than I think the equation actually is. But then you look at, right, who are the people who have a vested interest in this? Whose attention do you need? How do you actually get them convinced of why this is like an important idea? I think it ranges. This is just like a snapshot of maybe like just something, a place like UK where some of our efforts are focused in right now, but I think it definitely scales beyond that because in the past sort of like year, our work has gone from sort of national to more sort of international consortiums and World Health Organization. So you have really interesting actors in this landscape if you're trying to think from a policy angle. And I think media here is like a really interesting one that often goes undetected. I don't know if that's the right word, but MPs and ministers will always care about what the public thinks, especially before an election cycle, which we're heading into right now. Media can sometimes hold a little bit of the shoestrings on the kind of sensational pieces they might publish, which can or cannot affect sort of like public opinions about certain topic areas. And then regulators here, I think, is like another really interesting angle when you're thinking about policy, because everything that a regulator provides guidance on has like huge downstream effects on what the industry or research is or isn't able to do. Giving you a very, very sort of like quick thing on things you could be doing, or like some like tools we've tried and we're trying to like so that we get the right attention from the right people. So I think something that's been like a really interesting angle into like sort of combing through a lot of the pain points is actually getting the policymakers. So these are people or senior officials in health departments connected with the funders. This could be funding agencies, or this could be philanthropic organizations with the academics who are working on the research. So you effectively, as an advocacy policy organization and a mediator, try to create this sort of like three-way bridge between all of the right people, where trigger 1 escalates into trigger 2, into trigger 3, and hopefully by the end of it, you end up with the policy that you wanted or had in mind. So this is just like an example of something that we tried, which was significantly helpful in starting an internal inquiry in UK health departments on how to integrate something like human challenge trials in the UK's pandemic preparedness and biosecurity framework, just based on this report and event we did, which was like, I think, a really nice success or conversion ratio for the amount that went in. Another example in sort of like the spectrum of what solution making at this space could look like is sort of like adjacent to engaging with policymakers, engaging with funders. You also do a lot of like evidence submission, report writings, cost estimations, and evidence generation as well. So this is just an example of something that we submitted to the UK Science and Technology Committee a couple of months ago, which again was a huge significant piece in moving how the world is approaching pandemic preparedness. I will skip the slide again. Sort of like the last piece I want to touch on here is I think policy making, especially in this like pandemic preparedness space, because it's like huge, vast, and there's like so many actors involved, sometimes can feel a little bit of a pain point. You don't often know. It's very hard to evaluate, firstly, how much of a contribution you're making, and second, what the sort of outside impact of that contribution is. But then often there's like some ideas that come forth which can be quite rewarding when you're least expecting it, which help move the needle significantly. So a quick example I give here, and this is, I'd say, something we're sort of like shifting some of our work on, is like, or definitely something that's like back on the radar for a country like UK, is so after World War II, there was a sort of like a bunker facility in Salisbury in UK, which was an American military hospital, which was abandoned after the World War II, which the MRC, which is Medical Research Council in the UK, decided to fund to do common cold research. And this is like one of the oldest records of a country doing human challenge trials where you're deliberately infecting people with common cold strain to try and understand respiratory infections and transmissions. In the time that this unit was active, it produced over 1,000 papers. I think the number might be even higher than that. And it had this, if you look up like common cold unit, like YouTube videos or like old sort of pieces on this, it was advertised to people as like I don't know how many people are familiar with the idea of like Butlin's holiday for people, where people could like take a few days off work, go take part in this research studies in down south, and actually be like paid some amount of money for their time and taking part in this medical research. About 40% of everything we understand about how respiratory transmission and infections work comes from the research that was done at the Common Cold Unit during this time. Some estimate the number might be even higher, to about 60%. So it's a really important piece in our sort of like historical toolkit for how we've gone about understanding pandemic preparedness. And it was an idea that was sort of like put on our radar a while back, which is that a country like UK should revitalize its Common Cold Unit and sort of like bring it back so we can deal better and understand future transmissions way better. And I think we at the time like discussed it and thought maybe this is like an interesting idea, but we're like really unsure about whether a country like UK at the time was like ready to consider this. And then this piece came out literally like last month, I think, when I was like flying somewhere for some like meetings. And turns out that the vaccine task force chairforce in the UK decided to submit evidence to the UK Science and Technology Committee saying that UK should revitalize its Common Cold Unit and set up a Center for Excellence, they're calling it, which is meant to be this like central facility for pandemic preparedness where you conduct challenge studies on a regular period, which was exactly what we've been talking about for like years. So that was really exciting to see. And I think like last thing I'll just sort of like touch on in the spectrum of policy making and bio, especially as like people are thinking about being involved through this like sort of like career pipeline. I think a lot of the times when you think about policy making, especially in something like pandemic preparedness, the temptation is to think larger or bigger picture on like World Health Organizations or United Nations or national government policies. But I think policy can exist at several layers, starting from individual level all the way to international orgs. And I think just quick sort of like examples I'll mention here, going all the way to sort of like to the bottom and larger scale, is on an individual level, you have a lot of autonomy on the type of things that you can influence with your MPs in your local state. Something that's like incubating right now in sort of like Western world, I'd say, is this idea of individuals like owning and sharing their digital healthcare data and how that influences what monitoring for different infections over time might look like. On an institutional level, you can definitely think more about, I don't know, asking your companies to install our UVC tech that helps you protect against respiratory infections indoors. A couple of tech companies in Silicon Valley have been thinking about this idea in order to reduce the number of sick days that their workers are experiencing. And it's doing this sort of like downstream effect of market shaping, where it's getting the attention of other companies in Silicon Valley who are also thinking about installing technologies like this in their spaces. Scaling to sort of like local government, which is like your third layer. This involves, I won't go into this again, but local voice-border surveillance in your area to sort of national level biosecurity strategies. And then sort of like the last final layer here, put in a simplistic term, is sort of like international orgs that oversee a lot of these frameworks and make sure different units and countries are working together, which typically falls under the remit of something like the World Health Organization, or if you're thinking engineered pathogens, could also be under the Biological Weapons Convention, which I think I would have a much better idea about than. And I'll pass it back to him. Thank you.
Yeah, thank you, Jasmin. Before Greg starts again to speak about how to get involved, I would just like to let you know that EU Switzerland is organizing a biosecurity summer program. So it's 4 weeks in July and about 3 hours a week. I will give you some more information at the end of the talk. Yeah, it could be a great first step for anyone who wants to learn a bit more about this. Yeah, stay tuned. And I'll give the floor back to Greg.
Howdy. Hello again. Briefly from me. So yeah, pandemics are a big deal. And if you want to help, how do you do it? There's one thing which you might gather from these presentations is there's like a lot of different bits of biosecurity which are important. They span like a lot of different fields, from AI to technology to policy to medicine and public health, and the list goes on. And they often, any sort of useful project in this area often requires collaboration and coordination between multiple disciplines. So the aim is, I think, to try and become, in one sense, an expert, in one sense, a generalist. So the expert sense is it does help to begin to develop an area of particular interest over time, whether that be supply chains, whether that be policy, international relations, whether it be economics, and so on and so forth. So you have it, in a sense, like a home turf, which people know you work on, but also you need to have at least enough understanding of other areas so you can usefully interface and collaborate with others, because this is generally a team sport. I think there's more I could say, but maybe it's better we talk in concert. So I will pass on to the panel discussion.
Thank you again. Yeah, we now reached the Q&A portion of our event. So I'll be moderating the discussion, and feel free to use Slido to submit your questions. So yeah, now is the time to submit them and upvote the one that you want to be answered. Yeah, I'll start with one. What do you find most exciting and on one side and like most challenging on the other side in your field, and how do you navigate those aspects?
I don't know why you're both looking at me. Yeah, I think my answer to this might remain somewhat similar as yesterday. So I think something that's been actually a like new thing that happened that I think I'm excited about is I was just touching on sort of like different leverage points into shaping policy, even at an international scale. So like as a org, we do a lot of work on representing participants who take part in medical research at their autonomy, at their altruism to advance science. And recently, something like a country like India had been considering whether they should run human challenge trials going forward. And actually, we found out that there were a couple of volunteers who had previously taken part in a research studies like this, who were like flown to Delhi, the capital of India, and sat in like these hour-long grilling sessions with the ethics board there, talking about their experience and why they're doing this, not just for compensation or the money these studies paid, but also because they're really interested to advance the goals of science or these vaccines for people to care about, for the world. And that was like a really significant contributor in convincing the ethics board on ensuring that they give these studies another chance, and these studies don't end up being banned in a country like India, which I think is really important. So that's been exciting, something new. Something that I wished was like better is we've been discussing how with a lot of these risks, by risk, the underlying technology is getting cheaper and more accessible for people decade on decade. But if you compare that to our sort of like preparedness sort of like portfolio and ability to make some of these countermeasures and clinical research, the amount of money it takes to make a vaccine or antiviral and get it approved has been like getting more expensive year on year, like significantly, which feels a little bit like the other way around, given the underlying tech is cheaper. So why is like getting a vaccine approval getting more expensive? So that's been like something that's been sort of like an interesting problem in my mind.
Okay, sure. The exciting part is we can absolutely solve it, right? It's a solvable problem. We know the kind of causal chain from pandemic to, or rather like the causal chain from information or virus or whatever to pandemic. And we know the technologies and policies to stop that. The frustrating part is that we don't really, and we kind of entered again the neglect part. The momentum we had during the COVID pandemic, I think, did not result in the extent of investment in pandemic preparedness that many people hoped for. Still some, but not enough, I think.
Yeah, I mean, one thing a maybe more selfish reason I'm excited about working in this field is simply the wide span of like subjects and topics involved means I don't usually get bored very often in terms of what I'm working on. And I can range fairly freely. Even if you're specialized in one subject, it's nice to encounter like, oh, this is how like international relations work when it comes to pandemic treaties, vis-a-vis like biological weapons, or how the supply chains work. And the list goes on. So you definitely won't be bored if you end up working in the field like mine. The challenging area is kind of similar to what, for me at least, what Jess said. And maybe moreover, not only that lessons don't get learned, but you find out when you study stuff, the lessons could have been learned in the past, but weren't. One example I find quite interesting is that I think just after the Second World War, the US pioneered using UV lamps indoors in schools to like reduce infection rates. And it worked pretty well. They noticed like, oh, we're not getting like outbreaks of influenza anymore in these classrooms. And then nothing happened since. It seems like depressed. So I feel like sometimes you have like missed opportunities you feel like we're sometimes catching up on, but so it goes.
Thank you. There's one question on Slido. Where, in your view, does the boundary lies between helpful and harmful research? For example, storing smallpox in a lab, like it seems some of this is necessary.
I can have a crack. Yeah. So indeed, some of it is. And the dilemma of picking or trying to judge whether the benefits versus harms of research can be very complicated. Smallpox is an interesting one because there was like a lot of discussion at the time where they should eradicate the final samples. And somewhat ironically, that discussion was, in a sense, largely laid to rest by another piece of dubious research, because a paper I didn't show you was about 4 or 5 years ago, someone synthesized a virus like smallpox from scratch. We've seen it for other viruses. It's been done for polio, 1980 influenza, and so on and so forth. And so the argument of whether you want to like get rid of the last remnants gets a bit moot now, because even if you eradicate all of it, it could still be revived. So that, of course, itself is an example of like research, which is what is the benefit and cost of this? I'm not sure I've got a great bright line classifier of what is good and what is bad. I would venture that the judgments made about this seem to be both very error prone and also not sufficiently risk averse. Like the paper I showed you earlier just seems you don't need to have a PhD in virology to realize that was like maybe not the best idea. And so how one gets to the responsible and wise judgments of what path to go down in science is unclear. And I do appreciate there are trade-offs, because often people doing kind of weird or unusual things is how the scientific progress advances. But despite that, nonetheless, there is some line out there. We are crossing it quite a lot. I would like to find it and draw it more carefully.
Do you want to add anything? Another question from the Slido: what is your personal take on importance of pandemic preparedness versus, for example, global war risks or risks from AI?
I can have a go. Sure. I think pandemics are, for me personally, somewhere in between, right? I'm personally more worried about AI, just because it's much more uncertain, right? We don't really know what's happening. We don't really know how the future looks like. Whereas we do know what a really bad pandemic looks like, and we kind of can envision the worst case pandemic, even though we have never really seen it. But we would know in theory what it would look like, and like I said, we have in theory the tech to combat that. So that makes it kind of very rewarding and nice, and the scale is much larger than compared to some of the other things people might worry about, because again, biology can just like replicate, and it's very accessible. Biotech gets cheaper and cheaper and gets more accessible over time. But kind of this uncertainty aspect that AI brings with it, for me, is a bit more scary even.
I would just agree with that. I don't think I have anything to add.
Sure. I mean, besides issuing my agreement, there's a difficulty in terms of, I think if you buy the sort of triangles I showed you earlier about the vastness of the future and the importance of preserving it, then I think I have a very similar rank ordering of like AI and bio, some are up there, and then other stuff is lower down. One point worth making is, of course, these risks do intersect in a variety of ways. So one might be concerned about global stability and conflict, both in its own right, but also because it could feed into misuse of biology, but also maybe like worse AI development if you're also worried about that as well. I think if one is more concerned about the here and now, how one ranks things like my own field versus like typical global health measures is a little unclear. I mean, one thing worth noting, of course, is the death toll from bioterrorism or biowarfare this year or last year and the year before that was 0. So it's all anticipated on future risks being much worse. And if you don't have this long-termist, far future orientation, then maybe things like global health, again, rise to similar importance. But so that's a long way of saying I agree with the first 2 speakers.
Thank you. There's one that maybe Jasmin has insights on. Accelerating vaccine research might also accelerate the anti-vaccine movement. How do policies and organizations take that into account?
That's a great question. I feel like I hear this question at least once a day in like all of my daily meetings. So right on the money. Yeah, I think like there can be, it's like important to understand firstly why this like hesitation might exist. And then where like the public trust filters in, and like how does that influence what kind of research is allowed to exist. And I think it's actually really different for different countries, even localities. I think for if we talk to like some people who've been working in middle and low income countries, I think a lot of it might even stem from how historically medical research has been done, where a lot of these populations have been excluded from this research. So essentially you're like, let's take like a very simplistic, you have a sample of like 100 people that you're testing a vaccine on, let's just assume. So you're not taking the time to extend that clinical research. So you're excluding certain parts of the world and population, but then you're hoping to like extrapolate that data to the entire like rest of the world, which of course for a lot of people just like doesn't make sense, like they don't want to buy it. So I think like it's and yeah, like these things can have a huge influence for where this sort of like anti-vaccine, anti-science movement might originate from. A lot of it can also just be like really bad like political tensions. Some people don't trust the government in like localities or nations that they live in. Sometimes I think the public messaging is just like completely off, and that can be like improved way more. I think with this sort of like 100-day sort of mission framework that we're working on now, where like the underlying thing we're trying to achieve is acceleration to some extent. There are like really good sort of like stop and pause clauses, I call them, built in, which make sure that the inclusion this time for a lot of these populations and countries has been done better than we've done it traditionally, like in the past, which I really hope goes a long way for building a lot of this trust, and also like tackling the hesitation overall. But I think the question then to ask is like, just because we haven't like been able to deal with this well in the past, does this mean like, do we stop doing the underlying science that is like ultimately super important? Like probably not, is like my personal opinion. But yeah, that's my like attempt in thinking about it.
Does any one of you want to add something?
Yes, we covered.
Great. Okay. I have another one. It's hard to choose. Are you worried that global risks, such as like engineered pandemics, might lead to non-transparent surveillance and totalitarianisms?
You know that Boston paper probably better than I can.
Yeah, I mean, well, having fun to be a member of the Future Humanity Institute, there was a paper on like what to do in a vulnerable world. So one potential solution, like if everyone could do bioterrorism, is having some modern dystopian scenario where you're surveilling everyone all the time. I would hope about like slightly better solutions than that. I mean, my own hope, actually, in the long view of my field, is actually basically biological weapons are made technically obsolescent by advancing technology, whereby it doesn't even matter if someone tries to make something nasty and release it, it won't effectively spread or cause damage. So I hope it's like you get solutions that way. I'd also hope that maybe you could do like have slightly more finesse in your policy interventions to limit misuse without limiting everyone's freedoms, for example. So I think there's like a lot of earlier steps you could try and pursue. There's something in public health called the coercion hierarchy of if you want to change someone's behavior, what do you do? And like the very bottom step is you just ban it entirely. And I think in a similar kind of way, there's a bunch of intermediate steps I'd want to pursue first. So I'm not too worried about this stuff paving the way towards a totalitarian superstate, but watch this space, I guess.
Yeah, I agree. I think the deterrence or the technologies we have to combat that work also as a deterrent are just so good in theory that I think we won't really need the totalitarian superstate to enforce that. Fingers crossed.
And link a bit to that and to your previous answer, how do you think those risks maybe politically or like technically compared to AI risk, as you touched upon already a bit?
Yeah, I think there are kind of two angles you can look at that with the AI bio intersection. One is the AI risk that is routed through biology, and I think that's probably negligible, and you might just rather solve AI risk and not really care about biology, because if the AI is your problem, then just shutting off the biopath is probably not solving all of that. And the other side, the kind of uplifting side, where you just view AI as helping people to achieve whatever they want with biology, that just, it doesn't really, the AI for me personally is not really doing a magical thing there, right? If you can do it with CRISPR and there's no AI involved, that kind of still feels the same to me. Not sure whether that answered the question.
Not my question.
That's true, but you can read it.
Yeah. Anyone? Yeah. There's something more about how to get involved. So maybe Greg or maybe Jasper, because he's also more on the technical side. How feasible it is to use machine learning as a gateway into research or on engineered pandemics defense if the background in biology is lacking.
Yeah, sorry for my very short how to get involved spiel. I thought I'd skipped this sooner because I thought we might be running over time. So I think I often give careers advice via something called 80,000 hours. And I meet a lot of people who have like, I have a background in computer science or IT. I want to work in maybe bio. Is my lack of knowledge a detriment? And the short answer is like, not really. So I know people who are working in this area who stopped studying biology like 16 or 18 and now are working, for example, a software engineer at the NAO, I know, who doesn't have a biology background. A lot of people who do, there are a lot of like machine learning tasks which you could apply to biological things which do not require you to be an expert in the underlying biology. I think it's fair to say that becoming literate in the field of biology and stuff is useful, even if you're working on the AI ML side of the house, but you can pick that up, as it were, on the job. So yeah, if you have like a bunch of experience in ML, CS, etc., and you want to work in bio, we'd be delighted to have you, I'm sure.
Yeah, just +1 to that. I don't want to dunk on the life scientists too much. I'm a biologist myself, but the required knowledge you need, as Greg said, to become literate is pretty manageable. It's not super hard.
Maybe a bit linked to that too. Could you maybe share a bit more about your journey and like what might have inspired you to pursue this career? Maybe a pivotal experience or a mentor or a role model that inspired you into doing that.
Yeah, you get that.
Yeah, I think so. I'm technically trained, and biochemistry is like my OG background. I started out in academia in bioimaging and genetics, which were really cool science. I like absolutely loved it, but I realized I like hate being in the lab. Like I don't enjoy as much. So I decided that maybe I want to try industry science, which tends to be like probably at scale, has like much larger budgets. And so I spent a little bit of time in industry, which was actually working with machine learning pipelines to do a lot of the work that like normally a scientist would do. So like trying to like replace myself with like a machine learning algorithm, which is like fun to think about. But again, I think the science was amazing, but I don't think like the skill set was really playing to like what I thought were my strengths as a person longer term. And around that time, I started to get involved on this verge of this like thing called effective altruism, which like introduced me sort of like new ideas to approach about more like high impact interventions that I could be working on, which I think really like piqued my interest. So I decided to leave industry and try my hand at sort of policy entrepreneurship on utilizing building a nonprofit that try to utilize sort of like grassroots advocacy at a local level to influence MPs on a lot of the local bills that were coming into effect during the COVID-19 pandemic in the UK, which was sort of like my, I guess, sort of like fire and fuel into thinking more about sort of policy at a national level or bigger than that, and more this sort of like mix of sort of like entrepreneurship or like the things I'm working on now. And I think that was probably like a really big pivoting point in my career. And since then, I think I've been working on sort of like a different mix of like portfolio of like technical and policy things, but sort of the past 2-3 years more focused on the policy side and pandemic preparedness. So yeah, that's like a little bit of a primer on how I got here.
Yeah, I guess for me, the inspiration was mostly the realization that tech is getting better and we can actually make ourselves go extinct. And I didn't like that thought. Then I learned about biosecurity and GCBRs and worst case pandemic scenarios. And given my background, I was already in my master's biomedicine. And by then, yeah, I did my virology PhD and got into biosecurity.
Yeah. My Bildungsroman, I hope I use that word right. I only speak 2 words of German, I'm ashamed to say. I was working as a doctor about a little while ago now. Because I was a nerd, I sort of studied tried to work out economically how much good doctors do. The answer was, as I assess it, kind of disappointing. So I thought I'd like do something else instead. And as you might have noticed from the triangles I previously showed you, I'm kind of into philosophy. So, maybe I should think about what's the most important thing to work on. So it seemed like I thought for long-term future was the most important thing to work on. At the time, this was about 2012, 2015, can't exactly remember when. A lot of the interest was then and still is about AI, but I think, well, I have like a medical background, not a AI background, so maybe I should think about pandemics and other plagues. Started working in public health, and one thing led to another, and here I am today.
Thank you. I'll ask the last question to conclude that roundtable. Looking back at our conversation today, what key takeaway or insight do you hope the audience will carry with them?
All right, I'll start. The one that I said in the beginning already, it's solvable, right? We can actually make good progress on that problem. And it's very interdisciplinary, right? Whatever your background is, be it on the policy side, material science, ML, CS, bio, you can actually work on it, contribute meaningfully, and I find that very fulfilling. That's my key takeaway.
That was really wholesome. I don't know how to follow that. Yeah, I think I would kind of echo that. It is like there's beyond just like what's on the paper, there's like so many ways to be impactful in this space. So I think we're still like we could still use like so much more talent in biosecurity just going forward. So I do hope like we'll see more people even from this room joining the space. Yeah.
Well, basically said, I really don't have anything I can add, which is not repeating them.
Thank you so much. Before we conclude, I'd like to extend a heartfelt thank you to our panelists for showing up here and sharing their expertise and insights. I'd like to express my gratitude to you for showing up and engaging with the panelists and asking questions. Remember, the conversation doesn't end here. Keep the dialogue going on. We also will send you a follow-up email. If you registered on Luma, you will receive a bunch of resources to continue thinking and exploring this topic. And of course, we welcome you to also engage with the panelists during the snacks. I mentioned this before, we're organizing a biosecurity summer program, so you can scan the QR code on the left for more information. And if you already know you want to apply, then you can scan the one on the right. With that, I declare this roundtable over. Thank you all, and I'm looking forward to discussing with at least some of you during the snacks. And remember, this is the best chance you will have to probably talk with our panelists.